عليكم السلام. اللسان برازيل.
So, were there any practice sessions that you guys have finished for export importing? Yes or no?
Yes,
How was it?
this one. I did some schema tables and where you raw export to my AWS from.
You did it.
Yeah.
How was the? How did you like it?
Yeah, I like it because all my tables from my schema that I created from Nels, I all moved them to my AWS and my database there. It was completely empty. Now it's rich with all these tables.
Yeah. So this is part of the migration. What you just said. There are tasks like that because where they want the hardware to get refreshed. So this is basically they'll say, okay, this Saturday, this is what you need to do because we are shutting down the application, and you have 8 hours to do this. So some people they like if the database is small, they just use the export import or data form. If the databases are large, then at that point they will say, okay, we use RMAN, which we are going to learn next. Yeah. So some people.
Brother Mahid, few weeks ago, when you shared with us the method how to run the X authority, when we were like using the XNAME, right? And you took the notes and you explained to us about how to do it. You just forgot to send us that notes.
I thought I did that already.
I was like scrolling back all the way. You already explained it. You already took the notes, but you just forgot to share that file in the notes. If you find
Yeah, I'm looking into it.
Thank you. practice under export control.
Hangi diyorsun?
Oh,
Hayır spor akile en az önemli şu an. Hayır sosyal hayat.
morning.
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 I believe I actually put that on my blog. So check my blog. Yeah.
Awesome.
Yeah. So it is document ID 624
624.
with IIT or more.
So if I just open your blog and I will search for the document number, would you find it?
Here, I'm going to put it here. Did you find it?
Awesome, thank you very much. Is your blog private or it's public?
No, it's public.
Public.
This is, these are the steps, right? This is what we did that day.
Yes.
Yeah, I think this is it.
This is awesome. This is awesome.
So today's lecture, this is where we are actually getting into the redo logs, right? Now, do you have your SGA notes available? You may need that today. So most likely we will be done next Sunday if everything is going well, and then we can start advanced classes immediately after that. If I feel like we need one more week for this to catch up some of the old stuff, then we'll do one more week. But other than that, this is the last topic after the redo logs, and then there is only the backup and restore, which is left.
I see on the schedule it says next week no class, or that is all because
Let me look into that. So if we just go back and start everything from the very beginning, let's say Mr. Scott is right here, right? And he has his command prompt open. And from the command prompt, he is going to say, I'm going to use the SQL Plus, assuming that SQL Plus is installed. So first thing is SQL Plus is installed. So Oracle Client is installed. This is my assumption. And then DNSnames.ora file is updated. So basically what he did was, he said, I'm going to use the netcup and then I will create a new entry called batch 51, and then this will require the host name, the port number, right, and then the protocol and the service name. So host name is Florida, port number is 1521, protocol is TCP, service name is batch 50. So using the netcup, he has just created a connection string. Batch 51 is equal to this. So your DNSnames.ora file is being created. DNSnames.ora file is being created using the netcup. Now at this point, the next thing that he's going to do is he's going to start the command prompt, and he will say, using the SQL Plus, Spot ABC123 at batch 51. Right? Now, as soon as he hits enter, I want you guys to explain me what is the process that is going to happen. Now, the goal is the database is sitting somewhere here. So here is the Florida server. Right? So this is the Florida server. And listener is right here. Right? Listener is up, which is running on 1521. And there is a service called batch 51. Okay. So this service is pointing to a small amount of memory. But actually, instead of the small amount of memory, we will say this is the entire SGA. So here's your entire SGA. Right? So and then you also have another amount of memory here. And we call this the PGA. And here we have the SGA, and here we have this PGA. And this is where the database is sitting. Right? This is on U14. And then we have U15, U16, U17 for read block, U18 for archive block, U98 for archive, sorry, U18 for data block. And then we have U19, where is our backup. And our system also has the U01, which is the software, U02, U03, U04. These are all the control files. And then U05 is another area. This is for the flash recovery area. So this disk is your prop, right? These disks that you have are your control files. And this is where your Oracle software is. So you have the Oracle base, Oracle home, you have your TNS here. And this is where our database is. U15, U16, U17 is the redo group 1, redo group 2, redo group 3. And this is your data comp, this is your archive logs, this is your backup. That's what we talked about so far. Now, and then you also have a connection from here to the database. But they may be not a connection. But now at this point, the squad, right? The squad is saying, hey, you know what? I want to connect to the batch 51. Batch 51 is on the Florida server, and 1541 is open. It has a dispatcher, a service is called this, and then your instance is also called batch 51, right? Which is the SDA. And then you have your database that is also called batch 51. So Simi, can you tell me, as soon as the enter key is hit, what do you think is going to happen? Remember, this guy is still on the client, right? This is the client's laptop. And this is your server. And so far, he is still on the client. And he said, Oracle clients, I remember from Mo's class, Oracle client is installed, so he did 19C client, everything worked without any error. Then he created the TNS names.rf file using the netcom, and then he gave the entry. Every time there is a connection string that is called batch 51, go to Florida server, knock on the 5121, use the highway TCP, and then ask for batch 51. Perfect. So all this entry is good. He verified even using the TNS ping, and it worked. TNS ping is also good. So then he started with the command prompt, and then he said, I'm going to connect to this user. Now, as soon as the hit enters, what is happening in the background?
Well, he's already passed the list.
So, well, he is still in the command prompt, remember. He hits the enter, and then he will get into this prompt. But my question is, what is happening here? After he hit the enter and before he hit the SQL plus prompt, there must be few things that are happening that is allowing him to connect to the database.
It's verifying the credential.
Okay. But to verify the credentials, it has to come here, right? So when you hit the enter, and before you get the SQL plus prompt, one of the things that it is doing is verifying. But what exactly is happening next?
I was going to say it's just gathering all the information of your access for start to enter into ESQL.
Okay, so that information is already here, right? So he said, my credentials are this, and my database information is coming from here. So can I say in packet 1 is created and in packet 2 is created? Okay, so there are two packets that are created. One is the credentials, or basically let's just say there is one packet that has been created. Okay, so that this information can be passed along the TCP network and move forward. And then this connection is going to go, either it is the internet or intranet. If it is internal to the company, it is internet or intranet. Or if it is outside, then it is internet. So using this, he is going to find the server, and all along these two packets are getting fatter because the more it is, it has more routes that it is connecting, the more bigger, fatter the packet is. Okay. Now, Once it reaches the server, it says, okay, the server is reached. Which door to knock at? It says, okay, I'm connecting to 1521. And then it already has, from the packet, it knows that it has to connect to Florida, it has to connect to 1521, and then it also has to, whoever is asking. So now the listener says, where are you going? Say, oh, batch 51 is the database amount. So now, this connection here is called user process. Now let's say user process number is 100. It came out from anywhere from the computer, right? So let's say, and then user process is then handed to the server process. So let's call the server process number is 200. So basically 100 is handed to 200. So this one is the client, this one is the server. This is the guy who is asking, and this is the guy who is doing all the processing and giving it back. Okay. And we can get this information from reader process. A user process and a server process. Now, one of the job of PMON process is to clean up the orphan processes, right? One of the job of PMON is to clean up the orphan processes. Orphan processes are the processes where they are requesting to 200 to do something, and then all of a sudden they lost the Wi-Fi connection. So now I have a child process, but I don't have the server process. Sorry, I have the child process, but I don't have the parent process. So this is where Oracle PMON will come into it, and Oracle PMON say cancel, 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 do not send anything because the guy is no longer available. So basically what is happening here is this guy is saying, hey, you know what, I have a request and I need someone to dispatch that request, and then the listener is dispatching, and now I have the connectivity that is coming from our side and then going here. So this is 100 is handled by 200, and both of these can be looked at from the $3 process. $3 session is another one. Now a new session has been established. Now, at this point, it is inside in the SDA. The very first part in the SDA is where you hit the data dictionary cache. Data dictionary cache. And then it also has another cache, library cache. It also has another here, results pool or key pool. All this key pool. And there are a bunch of other pools are also there. This is the entire memory. So here, let's say my database SGA is 1 gigabyte. So maybe it will give about 100 megabyte to this, or 200 megabytes to this. Now the data dictionary cache, how do you define the data dictionary cache? Cesar, what do you think? How do you define the data dictionary cache? You watched the SGA video, right? So what is data dictionary? What do you think, Mustafa?
Data dictionary will saves all your hot phrase and cold phrase, have the execution plans for the.
I'm sorry, say that again. Data dictionary?
Yeah, it saves all your SQL ID.
No, that is the different pool.
The dictionary cache.
What is dictionary?
It's storage for certain words, function, I guess.
So if the dictionary information of the users or information of something that the Oracle is keeping. So data dictionary is basically data dictionary is the person who will be communicating with the system table space. So here I have the system table space, right? System table space has what? All the system related data. So when the database comes up from the mount mode to no, from open, in between that, it will come here and then it will get all the information about the data and then it will bring it back here. This is in between mount and then open mode. This is what happens between the mount and open mode. Now remember we talked about zoom out, which requires the SP file. Then we have the mount. Mount requires what? Control files. And then for the open, what did we say? It requires what?
Data file.
Data files. Where are the data files coming from? Table space. So now it is going to read that system table space and it will say, oh, there is a user called Scott. What is his password? ABC123. How many tables he has? EMP table, DEPT. How many views it has? All this. How many columns of each of these table? What are the data types? All this different information is being kept in here. What is the average row size? All this information about the entire database. So how many things the data dictionary is keeping? It is keeping the information about the users, tables, password, right? Tables, views. For the tables, it wants to know a number of columns,
The information of the database.
yes, number of columns, name of the columns. I thought we covered the SQA class, didn't we?
Yeah,
Did I not cover this in SQA?
No, you have.
Name of the columns, a number of rows, data type, permissions, yes, definitely. All these things, and then the views, triggers, synonyms, sequences, all this metadata information is being loaded into the data dictionary every time the database started or every time a data is changed. So somehow it has the mechanism where it communicates with the Bash 51 system table space, and then from there it gives that information. Now, can I say, if it has all this information, can the packets move forward now? And then the packets are going to the data dictionary. Hey, is there a user called Scott? Yes. The password, is that correct? Is this matching with what we have in the packet? Yes. If the password was sent wrong, ABC723, then in that case it is not matching, so you get the error. Right? So the user will have to come back and the user will say, okay, 1, 2, 3 now. And finally, everything is all okay. So this point, everything is okay. So then it will go to the library. Now it is just waiting. Why? Because the SQL, now you have to run. The user has to give a command. So user says, select this from EMP table where employee number EMP NO equal to 1111. Or select, let's say, salary. So show me the salary of an employee whose number is 1111. So here we have the library cache. Library cache is nothing but all the executed SQLs are sitting here. So if this is the very first time, it has nothing but an empty memory. Empty memory has the SQL ID and then the exact SQL text, and it also has a pointer. So in this case, it will scan through and it will say, oh, I don't have anything, right? But I'm looking for only one value. From the metadata it has, it will say, okay, now I have to go and get one particular block from user's table space. This block is sitting right here somewhere. So it will say, okay, now I'm going to go to the next level. The next level here is here, the largest pool, which is called the buffer cache. Right? So this entire space where it is sharing the pools, dedicated data dictionary, library cache, key pool, this is called the shared pool. Right? Shared pool is actually sharing multiple pools together. Now the buffer cache is the same size as your block size of the database. If your block size of the database is 8K, each of this buffer is 8K in size. Now what is another interview question? What is the difference between a buffer and a block? A block is something that is sitting in the database. A buffer is something which is in the memory, same size. So now it has all this buffer. So let's say if this is your 1/4 of your database memory, this is half of your memory. So this is 75% of your memory, the rest of the whole other one has. So all these 512 are divided into the blocks or the buffers of 8 kilobyte in size. Yes.
And that, in the buffer, that's where we have the free bin and the dirt.
That is here
That's on that.
in the block, not the buffer. Not the buffer. Block. Block, if it is on the hard drive, then it is the block. If it is in the memory, memory is something you turn off, everything is wiped off.
Right.
This is permanent. This is the disk, that's the memory. On the disk, it says, so if you have the disk, it is called the block. When the same block is copied to the memory, it is called a buffer. This is permanent. And this is temporary.
Sorry, I think he was asking that the status of the book, the block and the buffers, the different CREs.
No, I think he was asking about the percentage used, percentage free, right? PCT free.
So when we took notes in our SGM, I took some notes and said each buffer has a status, right?
Oh, the status.
So it could be either free, bin, or dirty.
Yes.
That's what I was just wondering if
Yes,
the right
that's correct.
Okay.
It's the same thing like block. Remember, block has the free block or pin block. Pin block is something that is being used. The free list is managing. So that similar way, something is managing the buffer. Right? So we'll talk about that. So now I have this. Now, if you recall, I said we have two doors for the buffer. The first door and then the second door. What is the first door called? LRU, least recently used. And here I have the most recently used MRU. So now at this point, since all the blocks are free, so now each of these blocks are either you have advertising itself as free or pinned or dirty. Right? Now dirty by select and then dirty by DML. Selects will go away from LRU side, whereas dirty by DML will go to the log buffer, which is the next one in the science. You guys remember this, right? I'm not going into the depth of it. And then we have the background processes like DBWR. So now at this point, let's just say this SQL does not exist. So it says SQL ID is 134. Text is this. And then since it doesn't have anything, it will pin this and it will say, I am going to pin one of the free block from the MRU side. And it will say, okay, I'm going to pin you. Now it will come, get a copy of this block, even though it requires only 1 megabyte or 2 megabyte, or sorry, 1 byte or 2 byte or 10 bytes. So for example, the value of the salary of 1111 is 7,500. 7,500 is the salary. So how many bytes it requires? 1, 2, 3, 4. Right? So my block size is 8192. So 7500 is only 4 bytes. So 8188 blocks. Even though it does not require that much, it will copy the entire block. Right? So majority of the space can be just the waste of space. And then it will say, now I have bring you here, you are dirty by select.
This was called hot blocks.
It is called the hard parse. Hard parse means something that is not found in the memory and it will have to do a round trip. So it will have to go to the disk, bring it here. Right? Now, I want you to type show parameter multi. So there is a parameter called multi-block read count. So type show parameter multi. is the value do you see there? 128, 50, 64 or 128 or 256? Show parameter. This is another interview question by the way. Is there a parameter called multi-block read count?
MULTI.
MULTI, that's it. Show parameter multi, MULTI. Or multi, however you want to pronounce it. So log n is DBA to batch 51.
So we have read count 32.
No. What is the parameter called? The full parameter.
DB5 multi-block reading count.
Okay, what is the value that you see?
32.
32. Okay. So again, guys, so the value 32, what that means is every time database required. So I need everyone's attention here. This is a very extremely important point for you to understand some of the basics of the troubleshooting. What that means is Oracle may have a bunch of requests like this, right? So what it will try to do is it will gather all the requirement and then it will send a user session to go here, and at any given time, how many blocks it needs to copy? It can copy 32 blocks. In each round trip, it can copy up to 32 blocks. So for example, you requested something, it is only one block. Okay? She requested something, she wants 9 blocks. So how many total? 10. And you request something, you want 22 blocks. So one round trip, because every time it is going to the disk, it is considered as a hard parts, right? So in each hard parts, it is trying to say, okay, 1 block from here, 9 blocks from here, and then 22 blocks here. So I got 32 blocks. So it will serve read our session. If you look at the process number, so process number 100, process number 101, process number 102. This is from user A, user B, and user C. I'm going to combine all these 3 transactions together, and I'm going to the disk, and I will pick up all 32 blocks. So before going to the disk, it will reserve 32 different blocks, because it will have to bring those values. So DB file multi-block read count, 32 is very low. Now, let's say if your database says, oh, I want to have, let's say 3,000 blocks that I want to bring. So imagine it has to go how many times now? 100 times, right? So instead of that, if I increase the DB file multi-block read count to 256, how many round trips now? 12, right? Instead of, if I have the 32, I have to go from the memory to the disk 100 more than 100 times. Whereas if I increase the DB file multi-block read count to 256, I will be 12 round trips will have enough output. So some people they like to keep by default it is 32, but we can go up to 64, you can go up to 128. Can you all change? This is a dynamic parameter. Can you change a value to a different value? So just keep it to either 32, 64, 128, 256, 512. I don't think 512 is supported by any operating system yet, but if you make 16. So try to see if you want to have a faster response time. If you know you have enough memory, you know you have enough horsepower of CPU, then you may want to increase this. So alter system set DB file multi-block read count to 64 or 128. And then going forward, every time it requires new fetch, this parameter will help you bring more. As long as your operating system is not stopping it, and most of the operating system should be able to handle it at least 128, if not 256 or even 512 or 1024. You should be able to make a change. So that's the value of the DB file multi-block read count.
So alter system set multi parameter.
So yeah, so alter system set And then the parameter name, db5 multi-block read count equal to 128, scope equal to both. So it will, yeah, by default, if you don't give anything, it is automatically scope equal to both. And then do show parameter again, and you will actually see that. So if your database has a lot of read requests, so it may be helpful for you when you increase this db5 multi-block read count. That way we can avoid multiple physical trips from the memory to that disk. Every time it is going there, it will have to look up, it will have to create a new process and all this thing. So Oracle will try to combine this into one round trip. Okay, can I erase this now?
That's good.
What is it? Oh. Okay. So after you change the value, do you see the new value now when you type in show parameter?
Yeah.
So you can do this on a system level, you can do this on your instance level, you can do this on a query level. So for example, you may not be a DBA, so you are not allowed to change this parameter. You are just a developer. So on your particular query, if you know that your particular query is going to get a lot of fetches, so on a query level also you can increase this. So this may be another task for you to do some research on a query level. Just on, you are a developer, you are Mr. Scott, you are trying to call DBA is not answering. So you want this to be done on your session level. So on a session level, how can I increase this? That means it is only for your particular session. So instead of alter system, we will say alter session. So it is only on your session level. Sometimes you have to do this on in your query using the hint. So you may also do some research on hints. So how do you know? So George is asking, how do you know to increase the RAM, right? Or the so how do you find out how much memory that you have
show parameters here.
So parameter SGA is one way.
Yeah.
On the physical side, on the physical server, how do you find how much memory the physical server has?
You use top one,
Sorry?
you use top one.
Top one is the CPU. They're talking about memory.
How much space size?
So your server must have three major components, right? Or four major components. The first one is the disk. The second one is the memory. The third one is the CPU, and then the fourth one is the network. So the top one will show you the CPUs, right? df-h will show you the disks, right? IAP config or IF config will show you the network. How about the memory? How do you check how much? Free minus h will give you how much memory that you have. So for example, if my server has 200 gigs and my SGA is only 32 gig and I have only one database, what does that mean? I'm wasting more than half of memory doing nothing. So in that case, you may want to look into the SGA resizing and stuff like that. So now you have the log buffer, right? So you have the library cache or shade pool. The shade pool, the memory pool is basically shared in multiple. So you have the data dictionary cache, data dictionary, and then you have the library cache. And there may be some other caches here. Two major are these. Then you have the buffer pool. Buffer pool is the largest pool in the database. And it is sized the same as your block size. Okay, so here we have the database is the block buffers are either free or they are pinned or they are dirty. Now if you have dirty by select, will age and basically move to least recently used site, and then exit. So you have dirty by DML, any insert, update, or delete will move towards the log buffer. Now, when we say age or move towards the log buffer, which background process is responsible of doing this?
DB writer.
Database writer, exactly. So DB writer. Now, by default, how many DB writers are there? Just one. So parameter writer, what do you see? So by default, there is only one writer. So what it does is, it basically does few things. Reorganize the buffer cache. How often it does that?
Every 3 seconds.
Every 3 seconds, buffer cache. Every 3 seconds. Right? So reorganizing means it is basically saying, I'm going to reorganize and then move something towards the LRU side. Anything that is no longer needed, which are called the cold blocks. And then you have the hot blocks. Any block that is a hot block, it means they are in between 3 seconds, somebody is keep using it. So it is keep pushing the buffers towards the MRU side, right? So a database writer, when you are saying reorganize, what exactly it is doing? Cold blocks will be moved towards LRU. Hot blocks will be pushed towards MRU. And then any block which is changed by DML is moved towards log buffer. Right? Database writer, so show parameter writer. So here I have the MRU side, here I have the LRU side. So in the data dictionary, we have the user's information, the table's information, all the metadata. Library cache, in turn, has its own dictionary, right? So it has the SQL ID, and then SQL text, and then it also has the pointer.
Last night's value.
Yes, exactly. So now it has all these SQLs, right? It just, you can think of that as a pointer pointing to the LRU, to the buffer hook. Now, here we also see that there is another door here. This door will lead to log buffer, right? Log buffer has an entry door, and then it also has an exit door. Entry and then exit. And this is called the log buffer. Okay? Are we okay so far? So this is where our read logs will start taking into here. So let's say I have this buffer as dirty by DML dirty by DML, 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 dirty by DML. These are the blocks that are dirty by select. Dirty by select. Majority of the times, database is reading, not writing. Dirty by select, dirty by select. So dirty by select are basically aging towards the exit. This is where we are getting into towards the database. And then I have some print blocks. And then database writer will keep the free blocks towards the LRU side so that it can fetch the more information. So here anything with the dirty by DML has to move towards the database because something is changed. A salary from 4,000 is now changed to 5,000. So here that entry, so this entry will start making into something called a change vector. Now, how do you describe a change vector? So now, change vectors can be very small or it can be very large, and then the change vectors keep going towards the exit door. Okay. So here the change vector is writing the timestamp. So now if I have to start looking into this, change vectors. So any buffer which is changed, which has changes, due to DML is pushed towards the, or any buffer which has changed is called change vector. Now, what exactly this change vector is keeping, right?
Yes.
So it is what is changed, who changed it, what is the old value, what time it was changed, and all this different other information, some XYZ information, so a lot of other information. So all this is needed to rebuild the block in case user performs a rollback, performs either a rollback or restore recovery. So anything that is changed, what time is it changed, who changed it, what was the old value, what is the new value, what is the SCN number, all the different things. So here, this is called system change number. Okay, every change vector has a system change number. Along with the system change number, it has all these other properties. So every change is called SCN. This is another interview question. What is SCN? So anytime a new SCN is being created, it writes into the control file. Anytime, so what is being written in the control file? Anytime a user hits commit, the change is created, it marks it as a permanent, it writes into the control file. Anytime a new update happened, regardless if it is a commit or not commit, an SCN is assigned. And then the change vector is now, so you may have only 4 bits of change. So for example, here the salary is 1,000 and you change it to 5,000, right? And 4,000 is changed to 5,000. So think about this. The old value is 4 bytes. The new value is 4 bytes. However, the change vector size, the only changes that I should be keeping is only 8 bytes, right? However, the change vector size is now 100 bytes. Why? Because it has all this additional things assigned. So change vector, SCN number. So now I have every SCN number. So some of these may have a lot of changes, some of these may have small changes. For example, I may just change the salary versus I may change the address. Salary is only 4 bytes versus address is about 25 bytes, right? All these changes. Now, all these changes, they exit towards. Now, your SGA is basically, that is starting here, and it is up to here. This is your SGA, main component. So maybe there are some other pools like Java pool, key pool, log pool, large pool, all the different pools there are inside in the SGA, but that is okay. So we have another pool 1 here. So pool 1, pool 2, pool 3, pool 4, and so on. So if you want to look into that, you can look into $SGA info, I think, and also $SGA, $SGA. SGA info, SGA, and then there are a bunch of other ones. You can look into that. So SGA info. These are the dynamic views that you can look into. You will see where you will see a lot of other pools and then parameters and all this, how it is balanced and so on. Now, this is all the memory, right? Now, this time it is saying, okay, I have U15 in here. Okay. This is U15. We are going to call this redo 01.RTO. And this is group 1. Then, and the size of this is, let's say, 100 megabytes. Then I have another redo log. This is U16. The name of this redo log is redo 02.RTO. This is group 2. This is 100 megabyte. Then I have the redo group 3, U17. Here I have redo 03.RTO. This is group 3, and we have 100 megabytes. Are we okay so far? Yes? Okay. So basically, all the changes that are happening, in case if I need to roll back, I want to roll back all the changes of last 7 days. So all the changes that are happening here are in the form of change vectors. So these change vectors are making their way into here. So now I have change vector 1, change vector 2, change vector 3, change vector 4, change vector 5, change vector 6, change 7, 8, 9, 10, 11. After 100 megabytes, it is completely full. So here, the status of this is, it will say, I am the most current one. Right? If it still has some space, it will advertise itself as I am current. Here it will say, not used, inactive. And here it will say, inactive, I'm not active. Why? Because the background process that goes from here and brings it here, this is called LGWR, log writer. So the background process that's called the log writer is keep writing to it, and I am the most current one. Okay, fine. Then once this is done, then it will say, okay, you know what? This guy has to be the current one now. So now it is changing this one, and this will say active. I will tell you why it is active, but the status of this will change to current. So now we have an active, a current, and inactive. Now, why do you think it changed from current to inactive? Because now the log writer start writing here. So this becomes the current one. But why is this still active?
Because it still has the value information.
It has something that Oracle needs. It has something that Oracle needs. Right? So here, what is happening here is it will say, okay, now I have to start writing this. So now you have more change vectors. Keep adding. And oh, by the way, the background process that does the switch, log switch, is the checkpoint, CKPD. So now you have to keep writing. At one point, it is also full. So by this time, this is most likely inactive. This will become active, and this will become current. You see the changes now? Yes.
Why aren't they both active since they both have information?
This is inactive. So most likely, whatever the Oracle was doing, Oracle says, I have all the information that I need. It doesn't have to be in the redo logs. So if you want to wipe off, you can do it. So basically, it is saying, I have everything, make it inactive. I have something I still need from it, keep it active. And this is the current. Why? Because the redo log writer is writing.
So it says, so active because it needs that information, right? So once you push it to the archive mode, that's when it changes.
So I didn't talk about that yet. So let's just hold on to it. Okay. So here, another checkpoint occurs. And then the log writer makes this one as active, and then it is keep writing. Okay. Now, once this is done, so now we have three groups. All the three groups are about to get filled. And finally, it says, oh, I'm completely full. Now, all the three groups are done. So now if I have to go back, so let's say each of this, so this is started exactly at 12 a.m. This is end at 12:10. This is started exactly at 12:10:01. This ended at 12:20. This is started 12:20:01, and then this started at 12. This ended at 12:30. So what does that mean? Just looking at this here, what do you think if I need to roll back? How far I can roll back? So right now I'm somewhere here, right? Let's say I'm somewhere here. Okay. So this is 12. So I have 12:27:53. This is my current time. So if somebody called me and they say, hey, you know what, roll back. So I said, how long I should roll back? And he says, oh, roll back all the 4 hours. Now can you roll back all the changes to 4 hours?
Here, 30 minutes.
Just looking at this. No. Can you go back? I say, no, I cannot do that. Then the guy says, can you at least roll back last 3 hours of changes? No. Can you roll back at least 1 hour of changes?
You got 30 minutes.
No. I say I can roll back only up to the 12 a.m. Why? Because I have all the change vectors that I can start rewinding up to the last movement that I have in here. So I can roll back up to the 12 a.m., but I cannot roll beyond that. I cannot go to the next day or previous day and so on.
When all of the U217s get full, does it get like flushed into a certain spot, or what is the process?
So the database can be kept into 2 different modes. The one mode is called no archive log mode. No archive log mode. Now in no archive log mode, basically this is it. This is a no archive log mode. You can only go back up to whatever you have in the redo logs. You cannot go any further. Why? Because now let's imagine there are more changes that are coming, more changes, more changes, more changes. At this point, a checkpoint will come in and then it will say, you are going to be the new one. So at this time, it wipes out everything it has and then it will start writing the changes. So this is at 12:30 now, right? So now imagine if somebody calls you, what is the oldest point you can go back? What is the oldest point now?
12:30.
No, 12:30, this is where I start reminding. So I remind all this and then I remind all this. So 12:10:01 is the latest I can go back. So this is what the no archive log mode means. No archive log mode. So if you have to write the property of no archive log mode means it is has limited recovery options, recovery time. Whatever the changes are in redo logs, you can only go back up to that point. That can be restored. That can be restored. Very fairly simple, right? Whatever the options that you have in no archive log mode, you have. If you have only 3 groups, if you have 10 groups, then you have bigger chance. If you have 3 groups, no, you can only go back up to a certain, right? And this is not a good practice for important databases. Important databases. For example, in production, right? So when is it good? This is good for testing or dev work. Only one user is doing is playing around. If we have a laptop, we install our database on our laptop, where we say, okay, even if it crashes, it is only going to hurt me, not my business. So in those cases, dev is this is much faster because it doesn't have to save these changes anywhere else, right? Are we all okay so far? Yeah. Now, imagine you want to keep all these changes. So what you will do is you will change your database into an archive log mode. Archive log mode. In the archive log mode, what we are doing is every time there is a checkpoint that occurs, we are writing into an archive mark point. So for example, U98, we decided that U98 is our archive log. So now I have the first change, the first checkpoint that occurs, you have change number 1.arg. Then the next one, arg, 3.arg, 4.arg. And then let's say you have 1 terabyte of space. In this 1 terabyte of space, if each of the archive is 100 megabyte, then imagine how many you have here. You can keep like 7 days or 10 days. So this is good enough for 10 days of archive logs. Now, they say, no, we should be able to revert it up to 30 days. Well, okay, no problem. Then you need to submit a request to increase the size of this from 1 to 3 terabytes. Now I'm keeping more data in here. Okay. This background process that writes from here to here is called the archive. There is a background process called arg. So imagine, and then it is keep writing. So it is keep saving. So it has all these changes. Imagine all these boxes are nothing but your archives that are sitting in here. At some point, it is going to exhaust out. So from here to here, we call this retention policy. So my database has a retention policy of 30 days. So whoever company, the department, they will have to sign an agreement saying that our SLA, service level agreement, is 30 days. We can not just rely on last 30 minutes of data. If you are here, we can go back all the way to here. And then if it is keep filling, then basically what it will do is it will say, okay, I have lost, I don't have enough space. At this point, you say, oh, anything older than 30 days can be deleted. So it will start freeing up some space here. So you may have to change this here, but anything older than 30 days is eliminated. So now you have free space here. Then the next day, it does the same thing. Now it has more rights here, but this is removed. The next day it has more rights here, then it will remove the old data. And so
Let's say on the 30th day, I needed a file, but exactly that's it.
again, remember how you had a last restore point available here. If I have last restore here, it is 100.r, and here I have 5,393.r here. I can only go back up to 100 here. Right? So now you have say, hey, the retention was only 30 days, and with that retention, I can only go back up to 100.r, which happened on October 3rd at 3 a.m. So I can go back only up to this one. So the information here, how do I find out what is the SCN number, what is the change number and all that? That is, that can be looked into $v log file and $v log, $v log and $v log, log file. $v log and $v log file, and we also have $v archive log, archive underscore log. That will also give you, I think $v log file is not the right one. $v log or log file, one of these two, I guess.
I did this right. The log file shows you the group number, status, type, number.
Yeah, check the $v log and we will talk about all this. I'm going to show you all this technical. But do you understand this part now?
Yeah.
Yes.
Right? So what exactly are we doing? We are saying anytime a change has made, the first time it is going to write into the log buffer, and every 3 seconds the database writer will come in here and then it will flush into by DML database. Okay, so I think I forgot one more very important point. So database reorganize, and then the next thing it will do is flush the change buffers to disk.
Yes.
Now, this is commit or not commit. Commit or not commit. Because 99% of the time, user make the changes to commit. So it will start writing to the disk, but it will just put a log. If the user say rollback, then it will start rolling back. But 99% of the time, when you make a change, you're not testing it. You're actually making the change, right? So that's what happens. So the buffer to the disk. So database writer has two jobs. One, it is organizing, and then the other one, it is going to start writing to the database as well. So database writer.
So we're gonna update the headers and remove those.
We don't do that, it will do it automatically.
On its own, right?
Yes.
You can update the blocks. the
Yeah.
values.
Yeah, so the time the user commit, it releases the lock. But if the user is not committed for next 15 minutes, it has put a lock on the change data, but the old data is still available for the users.
Yeah, because writers don't wait on readers and vice versa.
Correct. And then all these change vectors are being flushed using the log writer to the disk. So this is where the disk is, right? Disk, U15, U16, U16, and then U17. And also, this is also U14. So the database writer is flushing the commit or not commit data to the U14, and then the log writer is writing to the disk where the redo logs are designed, and then the ARC process is sending it to the archive destination. Anything that you have any confusion?
Question. So I think I should we have 3 different groups in the redo log. I think we have multiple numbers inside of
Yeah,
each group.
I'm coming there. So at this time, is this pretty clear? So a database can be no archive log mode or archive log mode. How can we find out what is the mode our database is in?
Select name and open.
Select log mode, I think. So describe $V database. Describe $V database. We'll show you if the database is in archive log mode or no archive log mode. So here the archive log mode. Redo is flushed to archive destination. Now, how can I find out what is the archive destination? We can type show parameter log underscore archive underscore dest. And then you will see, I'm going to show you all that. You can also find out what is the mode the database is in. So we can look into $V database. And I think the column name is called log mode, right? Log underscore mode. You can also see show parameter of archive. And then how much data should be kept? It depends on.
So that's log mode from
It depends on RMAN retention policy. And then we'll talk about the RMAN soon. RMAN depends on the RMAN retention policy. So is that log mode one word or log underscore mode?
Log underscore mode.
Okay, so from the $V, look into the log mode, and then that will tell you if your database is in log mode or not. Depends on RMAN retention. RMAN retention policy. And log archive list archive log. Can you type list archive log or log archive list? I think log archive list. Type the log archive list.
describe log,
Sorry?
describe.
No. Just type in on the SQL prompt form archive log list. Log archive list or archive log list, one of these. Check. Okay, if you are looking at my WebEx, archive log list.
Yeah, spaces in between. Archive space, log space, list.
Okay, so here,
And if you try database log mode, the automatic archive.
so here if I just type in archive log list. Yeah, so if you type in archive log list, it will also tell you your database is in archive log mode and all these other changes. So this is another quick one, which is called archive log list. So look into it. On the SQL first prompt, how to check database log mode. Right? So you can simply type in archive. So on the SQL prompt, you just type in archive log list. Archive log list. Or you can type select log mode from $3 database.
Do I know which archive, belong to which time? So if I want to say which go.
We will talk all about that tomorrow. Okay. So at this point, I'm just going to finish the class now. Just make sure that you take proper notes of this. You have ample time, and then write down everything that is needed. And then I think one of the major thing, that I have not told you is the sequence number. So you have, let's say you have the redo log group. So redo log group, right? So here and then log name, and then the size, and then there is something called sequence number. So for example, if I have redo log group, the name is redo, let's say r1.rdo, size is 100 megabyte, sequence number is 1. Then it performs a switch r2.rdo, then sequence, the size is again 100 megabyte. Here I have the sequence number 2. Then I have 3, so I have 3 redo logs, 100 megabytes. I have sequence number 3. So every time there is a log switch that occurs, it is also going back. So your redo log will never change, but your sequence number will keep changing. 7, 8, 9, 10, 11, 12. Right? Sequence numbers keep changing. So after 1, it will go to 2, to 3, then 4, 5, 6, 7, 8, 9. So redo log is not changing. Group number 3 has 9. Group number 1 has 10. Group number 2 has 11. Group number 3 has 12, and so on.
When the sequence change, that's when the group change, not when the number inside the group.
No, when the group changes, the sequence will bump up the last plus 1. But the group will always remain between. But the sequences can be because. So if you look into the database was created back in January, right, or sometime. So when the database was created, it was created with only 3 groups. We'll talk about numbers tomorrow. So with those 3 groups, my sequences are always bumping. But even today, right, we are in September now. Even today, the group number is 1, 2, 3, but sequence must be in thousands now.
It's incremental.
It is incrementing. Yes, every time it adds a new number. So make some proper rough notes that you can always edit when you go back.
Are we done today?
We are done for today. I will see you all tomorrow.